Welcome to day 18 of our course on design patterns. In today's session, we will cover two essential structural design patterns, the adapter pattern and the composite pattern. Let's get started. Structural design patterns focus on how classes and objects can be combined to form larger, more complex structures. These patterns aim to simplify relationships between components and ensure that systems are flexible and scalable. Today, we will focus on two such patterns, adapter and composite. The adapter pattern allows objects with incompatible interfaces to work together. Essentially, it acts as a bridge, converting an interface into another that the client expects. This pattern is typically used when integrating legacy systems or third-party libraries that don't match the expected interface. Imagine you are integrating an old payment system into a modern e-commerce platform. The old system uses a different interface than the one expected by the platform. By using the adapter pattern, you can convert the old system's interface into the one expected by the new system, making integration seamless. Here we define the adaptee, which is the old payment system. This system has its own way of making payments, but it does not match the expected interface of the modern platform. Our goal is to adapt this interface to fit the new system. Now we define the target interface, which is what the client expects. This interface contains the method that the new system will use to process payments. Our adapter will make sure that the old system conforms to this interface. This is where the adapter comes in. The payment adapter class takes the old payment system and adapts it to the expected interface. By implementing the target interface, the adapter allows the old system to work seamlessly within the new system. The key components of the adapter pattern are the adaptee, which is the old system, the target, which is the expected interface, and the adapter, which converts the adaptee's interface to match the target. This pattern helps integrate legacy systems without altering their internal code. For the exercise, you will implement an adapter for an old payment gateway. This will give you hands-on experience in adapting legacy systems to a new unified interface. The composite pattern allows us to treat individual objects and compositions of objects in a uniform way. It's especially useful when dealing with tree-like structures, where both single objects and groups of objects need to be treated the same way. Think about a file system where directories contain both files and other directories. The composite pattern allows us to treat both individual files and entire directories as components, simplifying the management of this hierarchical structure. Here we define the component class, which is the base class for both individual objects like files and composites like directories. The component class defines a common interface for all objects in the tree structure. In this step, we define the leaf classes such as circle and square. These are the individual objects that we want to treat uniformly. Each leaf class implements the common interface defined in the component class, allowing them to be treated the same as composite objects. Next, we create the composite class, graphic group. This class is capable of holding multiple graphic objects, including both individual leaf objects and other composite objects. By implementing the same interface, the composite class can treat all of its components uniformly. The main concepts of the composite pattern are the component class, which defines the common interface, the leaf class, which represents individual objects, and the composite class, which groups objects together. This pattern allows us to manage complex hierarchical structures easily. The composite pattern provides several advantages. It allows flexibility as new objects can be added without altering the existing structure. It also simplifies the handling of hierarchical structures, making the code easier to maintain and extend. In this exercise, we will create a composite structure for a menu system. This system will allow both individual menu items and nested menus to be treated as components, demonstrating how the composite pattern can be applied in a real-world scenario. Let's compare the adapter and composite patterns. While the adapter pattern is focused on converting interfaces to integrate incompatible systems, the composite pattern simplifies the management of hierarchical structures by creating both individual and composite objects uniformly. To summarize, the adapter pattern helps integrate incompatible interfaces without changing the underlying code, while the composite pattern makes it easier to work with hierarchical structures by treating individual and composite objects uniformly. Be sure to practice these patterns to master their implementation in your projects. That brings us to the end of the presentation. Do you have any questions or would you like to discuss any of the concepts covered today? Feel free to ask about the adapter or composite patterns or share any challenges you encountered in the exercises.